So students, welcome to our maths class. So today I am starting a new chapter, that is surface area and volumes. That is the 10th chapter in your textbook. 10th chapter, surface areas and volume. So this is the 10th chapter in our textbook. So before we going into the details, so you just try to understand what is the difference between 2D diagram and 3D diagram. 2D diagram and 3D diagram. Suppose, so if you see these two figures, you see this diagram. If you look at these two, this is, this is called a rectangle. It will have length and breadth. Rectangle will have length and breadth. There is no thickness. This is a rectangle. But whereas this is also look like a rectangle, but it is a box. Box. For package and all, packing something, we use this box. It is a rectangle box. So this is a rectangle. This is only a rectangle. So this is a rectangular box. The difference, this measurement is length. This will have some width here, and this is called height. So it will have three measurements: length, breadth and height. So this is called a 2D diagram, 2D figure. It will have two dimensions, length and breadth. So this is a 2D diagram, and when thickness also added, the box, this type of diagram is called 3D diagram, 3D figure, three-dimensional diagram, length, breadth and height. Suppose if you take, for example, a paper, so it will have length and breadth. It is a rectangular shape. Okay. Paper from your textbook or notebook, it will have a rectangular shape, length and breadth. Of course, it will have a thickness also, but if that thickness is negligible, it will have only two dimensions, length and breadth. But whereas if you take your textbook, if you take the textbook, it will have this length, this breadth and some thickness. So this type of diagram is, this type of object is called 3D figure. This is a 3D figure. It look like a rectangle, this and this, but there is some thickness. So therefore, one dimension, another dimension and another dimension. Three dimensions. So therefore, it is called a 3D figure. So this type of diagrams are called 3D figures. And when it is a rectangular box, name of this rectangular box is cuboid. This is called cuboid. So this is the difference. Normal 2D figure and 3D figure. So see here. Rectangle, square, triangle, circle, semicircle. This type of diagrams are called 2D figures. 2D figures. Rectangle, square, triangle, circle. This type of diagrams are called 2D figures. It will have like this. There is no thickness, only a plane. There is no thickness. But whereas this is also looking like rectangle, but there is some thickness here. So when thickness is also added, it is 3D figure. So these are the 2D figures. You studied about rectangle, area of rectangle, you studied perimeter of the rectangle, you studied length into breadth, area of square is side square, area of triangle is half base into height, area of circle is pi r square. All these you studied in the lower classes. So write down just difference between 2D and 3D just by giving these numbers. Write down the first point. Write down. The plane figures, rectangle comma square comma triangle comma circle comma sector are called 2D figures. Next, second point. Rectangle, square, triangle, circle. Second. See here. This is a box. This is also a box. The difference between these two is all sides are equal. It is a square box. The square box is called cube. Rectangular type box is called cuboid. Next, if you look at this figure, this is the ice cream cup form. This is called cone. This is our cylinder. We use this gas cylinder in our kitchen. No? This is cylinder. And ball. This is a sphere, not a circle. Sphere. It is a ball. So this is called a sphere. So this type of shapes, cube, cuboid, cone, cylinder, sphere, when it is having length, breadth and height, this type of figures are called 3D figures. Write down second point. Cube, comma cuboid, comma cone, comma cylinder, comma sphere are called 3D figures. 3D figures. Write down lateral surface area. See this area, this backside area, this area and front side area. So see it is having 6 faces. 1. See this side is 1. This side is 2, back side is 3, this side is 4, top is 5, base is 6, 6 faces. So in this if you take only 4 faces, so that lateral faces, that is called lateral surface area. If you add top and bottom, it is called total surface area. So write down. Sum of the areas of all the lateral surfaces or surfaces is called its lateral surface area. Sum of the areas of the lateral faces or surfaces, both are same, is called lateral surface area. Sum of the areas of all the lateral surfaces is called its lateral surface area. Lateral surface area. Write down the next fourth point, total surface area. See here, lateral surface area plus 4 faces and top area, bottom area also added, that becomes total surface area, plus area of top plus area of bottom is called, write down, total surface area. Lateral surface area plus area of top, area of bottom or base. Bottom is also called area of base. Is called total surface area. Total surface area. Fifth one. The formula for volume of any of these 3D figures is volume is equal to area of base into height. You write down. Volume is equal to area of base into height. Volume is equal to area of base into height. Sixth. Now I am taking the cuboid. So this is the cuboid. Lateral surface area. See here. Only 4 faces. What is the area of this face? This face is in the form of a rectangle. Area of rectangle, length into breadth. So length is L, breadth is nothing but H. So the vertical is H. This horizontal is L. So length into H. L into H, this face. This face is B into H. See here, plus this is L into H, this is B into H. Back side also same face, same area will be back side. L into H, back side also. Plus this is B into H, this side also B into H. So the formula for lateral surface area is 2 times of LH, 2 times of BH. So 2 into L plus B, this is the formula for lateral surface area. You write down. Write down this lateral surface area for cuboid. Now total surface area. See here. L into H, this area. This area B into H. Backside area also L into H. This side area, this is B into H, this is also B into H. Plus base is L into B, top base area L into B. If this is L into B, top area also L into B. So each is 2 times of LB, 2 times of BH, 2 times of LH. So this is the formula for total surface area of the cuboid. Write down. And third formula, volume is equal to length into breadth into height. Volume of cuboid is length into breadth into height. Write down these 3 formulas for cuboid. Lateral surface area, total surface area and volume. See here. Next is cube. Cube and cuboid, only the difference is cube means it is a square type box. All sides are equal. X, length is X, breadth is X, height is X. Then it is called a cube. All are equal. Generally it is denoted by S. Yes. Yes. So in this case, lateral surface area is this face, length into breadth, that is square means S into S, S square. This side another S square, all are equal. Back side S square, this side S square. So total lateral surface area formula 4S square. Remember this formula. And total surface area means this side S square, this side S square, back side S square, this side S square, base area S square, top area S square. So total is 6S square. Remember this formula, total surface area 6S square. Lateral surface area, total surface area, and third formula is volume. Volume of cube is length into breadth into S, S into S into S, S cube. So these 3 formulas, and cuboid 3 formulas, cube 3 formulas. So total 6 formulas you have to remember to understand or solve the problems. Okay students, understand these formulas and let us start the exercise in the next class.